Thank you for joining me today. We're taking a little bit of a late start, so we will try to wrap up at 11:30 so no one is late for lunch or your next adventure. You are both physically and philosophically not late to this conversation now. So not only did you definitely get to walk in a couple minutes after 11 o'clock and not be late for this session, you also, if you're new to DevOps, and hypothetically DevOps has been around for a while now, but you're new now, that's okay. This is what this session is for. This is also my lesson to never name a session, it's under control. What has happened is I don't have my laptop up here with me, it's in the back. I had a few demos that I was looking to do today, but we're gonna go to slides only. The other part of the good news here is that all of the code is in a GitHub repository at aka.ms/SQL source control, all dashes. So if you want to kind of do the demos yourself afterwards, or contact me with questions about it and that kind of thing afterwards, by all means, please kind of go through those code samples, and it'll show what we talk about in the deck today. I'm Drew Squires-Kabala. I work at Microsoft as a program manager. I work in the SQL tools team, which basically means for all of the SQLs, they are like my children. I love them all equally. When I talk about things like source control, I'm meaning for all of the SQLs. There's not going to be a catch of oh, it's just for Azure SQL Database, or if it's just for SQL Server. I avoid that at all costs because I want you to have tools that are going to work for what you're doing with SQL, whether you're a developer or an admin or a data analyst or one of those weird roles where you're changing hats every other hour. It's all good. There are a bunch of other Microsoft sessions here this week. You're about halfway down on that first column. After this is the Birds of the Feather lunch. Oh no. Thank you. But what we want to talk about today is not advanced Git. It is not going to be advanced deployments, how to deploy across 5 different regions and 3 different staging environments. That's not this. And I'm not even really going to get into database development practices or dogma about that. Whatever development practices you have now, I'm not here to change that. There might be other great sessions at this conference that will help you with that, but this is not this. What this is you have a real database and you want to get it into source control. You have some idea of why it's a good idea, or you've been told that it's something you should do. How do you get it into source control? Hopefully for not too much money, or with processes that you can implement quickly and then reevaluate down the road. We're going to be stepping into DevOps 1 inch at a time. The other place that this is really helpful, even if you are a DevOps expert, so if you're a DevOps expert and you're about to get out of your chair, hold on just 1 second. Because the other place that some of these concepts come in handy is you have an environment where not everything is the same. You have a bunch of databases where they've got great CI/CD practices, they've got the code check-in reviews, they've got stage deployments, they're beautiful. And then you have this database that you just dread dealing with because you don't have the same controls over it. The developers there aren't as willing to work on different things, or the admins want to keep specific controls. These kinds of practices where you step into DevOps 1 step at a time just with source control is very helpful in that situation as well. All right, so what we want in the world of DevOps, you can do the inner loop practices where you're doing local development and then checking things in. You've got the outer loops where you're taking feedback from what's happening on the SQL database. All we want is a single arrow where our database goes back into a GitHub repository or an Azure DevOps repository or a Subversion repository or whatever you're using. You want your database as code in a repository. We're not asking too much, which is great because we have 17 minutes left. Now, if you've heard my name before, which is possible but is also not likely, you know that I am fairly connected with SQL projects. Deck Effects, SSDT in Visual Studio, SQL projects in VS Code, Azure Data Studio. If none of that is ringing a bell, that is great. If it is, The good news is that if it kind of brings this pit of dread to your stomach because they're so amazingly powerful and complicated, all I want to talk about today, if I ever talk about SQL projects, is just the objects within it. So when I mention SQL projects, please do not panic. What I want us to think about using is a command line tool called SQL package. Now, in the world of demos, you can do very similar schema compare concepts with Azure Data Studio or VS Code. Those are both free tools that you can use with all of your SQL database products. But from the command line, why I jump here is because I want us to be able to automate it, but just running it once. SQL package is a CLI that you can install on Windows, Mac OS, and Linux, so whatever your environments are, you're good to go. It has a number of baseline operations, but one of them is extract, where it connects to a source database. In this example here is a localhost container because I am lazy sometimes. And then it extracts the database objects. It basically takes those objects out to their definitions. The default behavior brings them out to a DECPAC file. I did not name this. I cannot take credit for that terrible name, but that DECPAC file is great for doing those advanced deployments we said we weren't going to talk about today. What it is not great for is source control, because it's more of an artifact. What if you want files? We've introduced a property, a flag that you can set on SQL package extract operations, where you can say, I actually don't want a DECPAC. I want the files. Now, the options for extract target are kind of numerous to like, I just want a single file. I just want a folder with all of my objects not organized at all. Don't pick that one. But you can pick like object type folders. So you get a folder for tables, folder for store procedures. You could do by schema. If you have a nicely laid out database, you could do schema and object type. And what this gives you is an output of a bunch of database objects. Now, if you're doing this locally, you can then do your git add and git commit. You could do this from your friendly GUI environment for Git, but no major investment here, and you've got your database into code. That's great. You can check it into source control, keep an eye on things. Maybe you run this every so often and see if something has changed, but that's a lot of work for you. You already went through the work of installing SQL package, trying it a couple times, figuring out how to get it to work. What if your database opened PRs on itself? What I am proposing here, and the code is in that source repository at aka.ms/SQL source control with dashes, is think of your pipeline environments like a machine that you can tell what to do. And you say, hey, every week or every evening, I want you to run a SQL package extract on that database. See if anybody did anything funny. Make sure there's not any new indexes that don't make any sense at all. Or, hey, there's a new store procedure, or somebody changed this really important function. These are the kinds of things you don't want happening. That database was under control, but if it's not under source control, it's really hard to catch those things in some environments. So your automated environment, you tell it to run SQL package, you have it compare using the git status command, have those files changed. Now, in a pipeline environment, you can run CLI commands as different steps, and the result of git status will allow you to choose from the following steps. If git status returns changes, now your pipeline is able to say, I need to commit this into a branch and open up a PR. And if you've got this scheduled to run once a week, once a night, now you're suddenly starting to get these changes happening to your database. And now you've got PRs open that you can review. This works, and it's frightening, because now your database is telling you what's happening to itself in source control. So we've gone from getting our database into source control to it trying to keep itself up to date. Now, If you missed the beginning of this talk, miraculously, because we started 5 minutes late, but you missed this part where I said this is not about doing, the world's best DevOps. This is about getting that first step to where at least the database code is in source control. Thank you. And so you might be looking at me like, well, why do I have to keep track of the database? Shouldn't the developers be doing this? Well, the thing is that sometimes you have to motivate people. You have to say, look, it's in source control. Now we're getting something good out of it. Will you reconsider how we're doing things? So once you started to get your database into source control, you've proved that it can be done. And depending on how it's working for you with SQL package, you might say, this is the solution for us. Great. If this wasn't the solution for you, please do let us at Microsoft know how we can improve SQL package. But sometimes it doesn't work for every development team, every environment. And so there are a bunch of third-party solutions that do then augment the ability to bring your database in source control. I do not poo-poo on those at all. And if they work great for you, all I want is your database in source control. But now you've got that history of your database objects in source control. Let's go a little bit further. This is that scary thing that I mentioned that we would have to touch on just briefly. A .SQL proj file. They're much smaller than they used to be if you're using the preview SQL projects. This 7-line file allows all of those files to become a model again, to become a database again. You're able to validate their references to each other, and then you're able to do some more advanced things like unit testing, which amazingly can be done on databases. It's fantastic. So if I need a .SQL proj file along with all of those database files, there's a couple ways that I can do it, but the good news is that they can be automated. Because I don't want to stray too far from being able to make something else do the work for me. Again, running SQL package locally was kind of a chore. I talked a pipeline into doing it for me every night, opening up a PR, letting me know, hey, somebody added a column to a table, it's nullable, this is probably a bad situation. But you can use that SQL project file to get yourself to things like being able to create lightweight development environments. Now, all of those SQL files, you obviously don't want to open them up one at a time and hit execute in SSMS. I know at least one of you was thinking about doing that a few moments ago. Please do not do that. That's the hard way. You will regret it. You'll get 5 files in and you will have lost track of the foreign key relationships. Use the SQL projects in this regard. So when you add that SQL project file, one way to do it, other than just copying and pasting those 7 lines into a text file like I showed before, you can use the .NET CLI. I get a little torn when I talk about using the .NET CLI, frankly. No hate for .NET. But SQL Server, Azure SQL Database is not just for .NET developers. So you do not need to be building with C# to use SQL projects. You just need the .NET CLI. You can do a .NET new SQL proj, and it will make that file for you. When you run .NET build, it'll check all of those files and compile them into that DAC artifact. You don't even really need to worry about it, but you do need it so that SQL package can run a publish. The only reason why you care about this, not the only reason, but one of the biggest reasons why you might care about this is this might become one of those carrots that you get to use now that your database is in source control. Because before, your database was out somewhere living and breathing, and to make development environments, you might have to go grab a backup, sanitize the data out of it, or script it all out to files, and then do that whole terrible thing about executing them from SSMS like I just told you not to. But in this regard, once your database is in source control, if you build it into a DAC pack, you can publish this to a new environment, and it's going to give you an empty database, empty, no data, but it does at least have your objects. And in some development pipelines, not like automated pipelines, development processes, this can be really helpful to get these lightweight environments where you can check how is this stored procedure behaving, what are these table relationships look like, so you can get these faster. Could even just be for containerized development. So that's one relatively low risk carrot. Now, we have our database and source control, and so we have to kind of ask ourselves, what's the best next step for my team? What do we need? Do I have a bunch of developers that are either junior or senior and think they know everything, and they're doing Lord knows what to the database? And so I want to make sure that I'm able to do more code analysis, so really just review what's getting added. Is this database fragile? Do I have stored procedures that are longer than they should be, and I want to make sure that their output doesn't get changed? Unit tests are great for that. So when it is right for you, you can go further from that source control to things like unit testing. There is a proof of concept level implementation in that sample repository where instead of interrupting development processes, I am not going to require people to have unit tests before they check in their code. What I am going to say is when my database opens up a PR on itself, because it's source controlling itself now, it's going to run the unit tests that we are building. You could have a huge database that has no unit tests today, and instead of taking on the daunting project of having to write 1,000 unit tests, 10 unit tests, 1 unit test is even hard. Just start from doing this kind of backwards, and so you can run this ad hoc even. The T-SQL-T unit test framework is an open source project. That is the one that I used for this implementation that does the sample. So open source, free for you to use and test out in your environment. I know that there are, again, other opportunities on other products that will do unit testing, but for getting started with source control and trying out different things with it, this does layer on very nicely. So we were able to get through things without demos today. I do really encourage you to go grab that sample code because it is going to show you and walk you through that automated pipeline, kind of the real big nugget here where you can have your database put itself in source control by running the SQL package extract with the extract target set to schema or object type. And then once it has done that, it's taken all those files. You could do that locally on your computer if you really like doing things again and again and again, but automate it. Make it do it for itself. And that's what it has there for you in the example there. I know it's a GitHub Actions example. It works in Azure DevOps. The syntax is very slightly different, but the concepts are all still the same, so it'll work for your environment. Thank you so much. I really appreciate it. If you have questions, I'm going to hang out in the hallway back here, give folks some time back to head out. Thank you.